Hi everyone. I'm really excited to start this machine learning series, and I have done the full data analysis in Python series recently. You can check uh, in the different sections. There's a full playlist for our data analysis using the Python. And the next step is obvious. I wanted to do a machine learning series too, and this is what I'm starting today. So in this video, it will be more on the theoretical, plus I have an example I would like to share. And the first, let's get started with our first definition of what is machine learning and why do we want to learn this, right? And if I just got with the very engineering oriented definition of machine learning is, and I'm quoting is, a computer program is set to learn from experience E with respect to some task T and some performance measure P. And if its performance on task T as measured by P improve with the experience C, that means machine is learning with the data. Yeah, it's a field of study that gives the computer the ability to learn without being explicitly programmed. So what is mean by that? So in the software, the application or any program which we are getting, we are constantly making it, updating it, right? And we have very defined approach. So this is the data, this is the function, it's our input, it is going to provide some output, but we are giving the commands here to the program, to the application to do some certain task. But in the machine learning, what really happens is machine learns from the experiences, from the data. So what we do, there are certain models where we feed some data and it learns using that data. And when the new data comes, it uses the previous experience, previous data set which we have fed in the training. Using that experience, it provides the output. So that is what machine learning is all about. And it goes back. Machine learning is not new. It goes back like 50, 60 years back, right? And the very famous or the first example in the machine learning is and you might have seen that is identifying your email as the spam or ham. So HAM is represent your email is authentic, whereas the spam means your email is it is not it is a malicious, right? It is something which will harm your computer, your system. And to identify between these two examples, that is what the first or the very famous machine learning task was done, right? And what happens if we use the traditional approach? So I'm just coming down here. What happens if we use the traditional approach? So we know the problem. So the problem is we have to identify the emails which are coming in our inboxes, whether to it is put in a two category, whether it's spam or whether it's a ham. So we might, if we use the traditional approach, we start writing the rules. Okay, if the uh, email ID contains some different domain, then it might be a candidate for the spam. Or if the signature in the email is different, so we will start writing all these rules and we evaluate our email against those rules, and then we'll just put it into production. But let's say you have 10 rules and the hacker is aware of those rules, right? So you have to keep updating, or he will or she will try to override your rules. So that's not a good approach, right? It's doing the work, but in the long term, it is not automatically identified. So you have to constantly work on your rules to make it up to date. On the other hand, what the machine learning approach does, so you have know the problem, we know the problem, we have to identify the email, we have to train our models, right? And using the data, we are going to train our models, we are going to test it, evaluate it, and then we'll put it into the launch. So in this case also, as you can see this data, this becomes our data after some time. So you have to keep updating your, you have to keep training your data with the new, your model on the new data. right? And again, uh, that's becomes you are doing something on the model, right? It's not very automated. Still, you have to keep doing something. There is a additional approach on the machine learning which is something like this auto update. So there is a new data which always comes, right? And you train your model, you evaluate, you launch into production, but once the new updated data comes, it's again train your model. So it's a continuous automated process which makes the machine learning very, very intuitive and very helpful in this kind of examples, right? In this kind of scenarios where we are identifying whether the email is the spam or not. Now, coming to what are the examples of applications of machine learning, what are good candidate where we can use machine learning, right? So these are some of the examples, right? And first one is the detecting the tumors in the brain cell, right? So this is a semantic image segmentation where each pixel in that image is classified, and that can be done using the CNNs or transformers. Next, we have automatically classifying new articles. So this is something natural language processing uh, problem, right? And especially the text classification, which again can be tackled using the recurrent neural networks, the RN or CNNs, but transformers works even better in this case. Next, we have automatically flagging offensive comments in the discussion forum, right? Like Reddit or Discord. So again, this is the NLP problem here. Next, we have like forecasting your company's revenue next year based on the many performance metric, right? So this is a regression task where we are predicting something and maybe tackle you using by any regression model such as the linear regression or polynomial regression. If you want to do many degree of uh, features analysis, you can use that. Also, you can use the regression support vector machines, and regression random forest can be a good candidate here, or like artificial neural network, again that can be used here, right? So it's all depends upon if you want to take into the account of sequence of past performance metrics, you may want to use the RNCNNs or transformers, right? This is very famous one you might have seen, detecting credit card fraud. So it is the anomaly detection. Let's say you spend around $1,000 of your money regularly, and suddenly there is a $50,000 uh, spend, right? That is the outlier. So that is the anomaly detection, right? So anomaly detection, which can be tackled using isolation forest or Gaussian mixture model or autoencoders. So this is how you can use many different machine learning model which are already there. You can use, and these are some of the examples just to give, like in every industry, the machine learning is applicable in today's date. Next, let's see the what are the types of machine learning systems we have. So we have the there are many types, but I will keep is to three main categories here: the supervised, unsupervised, and the reinforcement learning. So there are others like semi-supervised or self-supervised are also considered the type of the machine learning systems, right? So if we talk about the supervised learning, so what the example which I gave earlier, identifying your email is the in spam or ham is the supervised learning because we are labeling something, right? So in the supervised learning, the training set what you feed to the algorithm include the desired solution, something like label, whether spam or ham is a label, right? And in the training set you train the model with the labels. You tell the models, okay, if this is the criteria, that means it's a spam or it's a ham. And a typical supervised learning task is called a classification. So and sometimes the regression model can also be used for classification. For example, the logistic regression is commonly used for classification as it can output values that correspond to the probability of belonging to the class. On the second, on the other hand, the unsupervised learning, where it is unlabeled, means like there is system trying to learn without teacher, you can say, means there is no prior labels. You have to identify using the data, uh, like models itself identified using the data, whether it is what kind of a grouping is there, like clustering is one example of this, or you can say visualization algorithm was a good example of supervised learning. Right? You feed a lot of complex unlabeled data, and they output 2D or 3D representation of your data, which can be easily plotted. Also, the dimension reduction, I think, is comes uh, in the unsupervised learning, and where what we do in the dimension reduction, let's say you have you have a lot of hierarchical or multiple features, and you want to reduce into few. So that is the part of the dimension reduction, and it is also called feature extraction. And the anomaly detection in the credit card fraud is the part of your unsupervising task only. And likewise, there are many others which are the novelty detection you can think of, like is the part of unsupervised learning. Next, I want to talk about the reinforcement, and where reinforcement is it's very difficult, or I would say very different. In this, there are something called agent, right? What they will do, they will the agents, they will perform something on your data, right? It's more, you can think of the robotics, right? In the robotics part, there will be a commands, and the agent, in this case the robot, will learn from its behavior. Let's say there are two options, like option one and option two. Option one is bad, option two is good. And if the robot chooses option one, that is bad, so there are action, right? It's a penalty. But if the robot chooses option two, then it's a reward. So it works on the reward and the in the penalty area, and using those, if it's just to get something done, you need to have like multiple rewards here. So that's how you're completing your task. And if you are doing wrong, then you are getting penalty, so your records are doing going into minus. So it just repeat same thing and again and again, and based on the penalty and reward, it calculates, and your decision or your success parameters is decided based on those uh, two things, right? Your reward and penalty. It is majorly used in the report robotics area. Next, there are also, I would like to touch base on the batch versus the online learning, and what is the batch learning. So in the batch learning, the system is incapable of learning incrementally. What is mean by that? It must be trained using all the available data. So you train your data with all the data you have, and this is something sometimes called offline learning too, and then you put it into production. When the new data comes, you again train it all the data, and then deploy again to the production. That is what we call the batch learning. Means it just new data comes, you have to redo it again, and uh, put it into the production uh, for the actual work. On the other hand, the online learning, it's you train your system incrementally, means by feeding its data sequentially, and you can do it into the groups like mini batches. So that's what the online. So it is a continuous data is coming. Your model is keep learning using those incremental new chunk of data, and keep updating. So that's a difference between the batch and the online. So batch we use when we have to do one time, and your model is keep working fine, or if there is continuous need, like online learning, you can think of the best example would be the stock market. So the stock tickers, new data is coming continuously and you have some strategy you want to apply, you already applied using the model, and you want to use that new data and feed into your model. So that is the online learning here. Batch would be you trained your model on something with historical data and you want predicting or doing something using the historical data. So that would comes under the batch learning where the data is not coming as frequently as supposed to be. Next, I have an example here, and I would like to run that. So these are some of the libraries which we are going to use. Matplotlib is used for the visualization. NumPy, Pandas are used for data analysis, and sklearn linear model. So this is scikit library where we are going to use the linear regression here. So let me run that and let me load the data as well. So this is the data I have. It's data of the countries, the its GDP and the life satisfaction. Means if what we are trying to predict here or are identifying here is based on the GDP of a country, what is the life satisfaction which the people living there find. So we have we have a list of all the countries here, right? And this GDP and the life expectancy. So this is our training data, right? So uh, what we are going to do, we are going to use this data, right? The X parameter is the GDP and the Y parameter is here the life satisfaction. So I'm just putting all those values here, X and Y, and this is the X values, putting into array 1D, one column array, similarly Y, and let's visualize our data. So this is the PLT is nothing but plot. We are doing a scatter plot here. So this is the GDP, this is life satisfaction, whatever we have data here, right? Axis limited the axis to starting from 25,000 to 60,000. It's 4 to 9. X label, Y label, grids true, and this is what we have. And let's use the machine learning here. We are using the linear regression putting into model and training our model. So for training, I'm using the model.fit x and y, right? And let's make a prediction. So I'm just giving the new value here, new country value something, and using that model, we are predicting and giving this. So it is the output which we got is 6.3. Right. So if the GDP of the country is this, and let's me change something here and let's see. So it's, you see, it's, so what we have identifying here is it's a linear relationship. Means higher the GDP, higher the life satisfaction. What we are observing here using, as you can see, if you fit that line here, higher the GDP goes and higher the life satisfaction. So it's a linear relationship. We can get this insight. Okay, it's a linear relationship here. Is this correct? Maybe or maybe not, because we are not giving more parameters here. We are just using two parameters of GDP and life expectancy and trying to get some output. So in this scenario, if we have to use only two, it's correct. But if there are, and in real life, there should be more parameters, and we'll see. It can be the like population, the GDP portion spent on the education, the air quality, and lot of parameters before we come up with the life satisfactions. So just to give you the hint of what's coming next. So this is what is machine learning, right? What is the previous approach, what the machine learning approach, example, types, batch versus online, and one example. We have just seen first machine learning models, how it works. So, lot more will touch base on the many algorithms we have. We'll see the example of the live codings. Thank you for now.